First of all, we write the equation for the force, F equals ma. In this case, we will write it as x double dot, which is the second derivative of distance with respect to time. This is equal to gamma mm2 over r squared, which is Newton's universal law of attraction. We can also say that the mass of the sphere equals ROV equals RO 4 over 3 pi r cubed, where 4 over 3 pi r cubed is the volume of a sphere. Also, from Newton's universal law of attraction, mg equals gravitational force equals gamma mm over r squared, where r is the radius of Earth. Capital M, the mass of the Earth is equal to ROV equals RO 4 over 3 pi r cubed. By combining these two equations, we get that mx double dot equals mgx over r, where x is the distance to the center of the Earth. We can see that this is a differential equation for inharmonic oscillation with solution I sin of omega t. This gives the period of 2 pi square root of r over g, but we need half of that time, because a full period would mean that the object would descend to the other side and come back, making a full turn, so we need just the time for it to reach the other side of Earth. By putting numerical values for g as 9.81 and r as 6,550 kilometers, we get 2,558 seconds, which is approximately 43 minutes. This is problem number 4.29 from the Irodov book. Now, for the second part, we know that speed v is the derivative of x with respect to time, and because this is an harmonic oscillation, we know that the equation for x is r cos of omega t. In this case we use cosine and not sine because we start from the initial distance r from the core of the Earth, and cos of 0 is 1, when t equals 0. After differentiating x with respect to time, we get v equals r omega sin of omega t. If you want to know where I got that from, make sure to subscribe to see my next video on derivatives. We use v in module because we want the positive value. The minus shows the direction of velocity, which is opposite to that of the coordinate system. To get omega, we look at the form of the harmonic oscillator equation, x double dot plus g over rx is equal to x double dot plus omega squared x. So, omega is equal to square root of g over r. After putting it in the initial equation, and setting time as t over 2, because we want it at the exact moment it is at the center of the Earth, as t is the time it takes to cross the entire Earth, we can do the maths and get v equal to 7.954 kilometers per second. If you want to learn more, then please, for the love of physics, subscribe and like this video.